Topic we are going to discuss about is chemistry of hydrocarbons, and the subtopic is structure of benzene. Let's learn about the discovery of benzene first. Benzene was discovered by Michael Faraday in gas produced by the destructive distillation of vegetable oil, and 20 years later found in coal tar by Hooch. If we talk about the molecular structure of benzene, its formula is C6H6. It indicates that it is highly unsaturated compound. In the previous slide, we talked about the molecular structure of benzene. Let's learn about its straight chain structures. Two possible straight chain structures for benzene are 1,5-hexadiene and 1,5-hexadiene 3-ene. But benzene is stable for alkaline KMnO4 solution, gives addition reactions with hydrogen and halogens. अगर benzene एक unsaturated compound है तो इसको substitution reactions reluctantly show करने चाहिए, but benzene also gives substitution reactions with concentrated HNO3 and H2SO4, indicating it's a saturated compound. Capable of forming one monosubstituted product. Molecular formula doesn't correspond to any other open chain compound. अगर आप इसका molecular formula देखें तो it should make at least 3 monosubstituted products, लेकिन ये सिर्फ एक monosubstituted product बनाती है. So in order to describe the structure of benzene, Hughes put forward its structure of benzene. He proposed a cyclic regular hexagonal structure for benzene containing 3 alternate single and double bonds like this. It's a cyclic hexagonal structure with alternating single and double bonds. He put forward the following postulates. Benzene gives only one monosubstituted product. So here you can see आप सिर्फ और सिर्फ एक ही substituent को benzene के अंदर add कर सकते हैं. If we want a monosubstituted product, तो हमें similar substituted product मिले. Benzene only gives 3 disubstituted products. एक ऑलरेडी सब्स्टिट्यूट प्रेजेंट है बेंजीन पे, उसके प्रेजेंस में जब आप y सब्स्टिट्यूट एंटर करेंगे, it will form 3 different disubstituted products. Here you can get 1 2, here you get 1 3, and here you get 1 4. The next postulate is benzene adds 3 hydrogen molecules in the presence of a catalyst. क्योंकि बेंजीन में 3 डबल बॉन्ड्स हैं, तो उन डबल बॉन्ड्स को हम 3 मॉलिक्यूल्स ऑफ हाइड्रोजन के साथ सैचुरेट कर सकते हैं इन द प्रेजेंस ऑफ प्लैटिनम एंड 200 डिग्री सेल्सियस टेम्परेचर टू फॉर्म साइक्लोहेक्सेन. So the next postulate is benzene adds 3 molecules of chlorine in the presence of sunlight. So वही 3 डबल बॉन्ड्स हैं, उन्हें हम हाइड्रोजन की बजाय अगर क्लोरीन से सैचुरेट करेंगे, it will form benzene hexafluoride. So these two postulates confirm कि benzene में 3 alternating single और double bonds हैं. The X-ray study shows that hydrogen and carbon atom are in the same plane. All the angles are of 120 degree, and all the CC and CH bond lengths are 1.397 angstrom and 1.09 angstrom respectively. यहाँ पे आप देख सकते हैं it's a hexagonal structure जिसमें कार्बन एटम जो है वो प्लेनर है. CC bond is 1.397, जबकि जो CH bond है that is 1.09 angstrom, और जो एंगल हैं that are 120 degrees. So let's learn about the objections that were imposed towards the Kekule structure. Kekule's formula of 3 double bonds demands a high degree of saturation from benzene, but usually it exhibits saturated character. Benzene में जो कि 3 alternating single और double bonds हैं, तो इसको unsaturation ज्यादा शो करनी चाहिए, जबकि ये सैचुरेटेड बिहेवियर शो करती है. बेंजीन ब्यूटेट सब्स्टिट्यूटेड प्रोडक्ट्स रेडीली और एडिशन प्रोडक्ट्स रिलक्टेंटली शो करती है. दैट्स व्हाई वी आर सेइंग कि ये सैचुरेटेड होती है. एंड बेंजीन इज आल्सो अ स्टेबल कंपाउंड. लेट्स डिस्कस अ क्वेश्चन. CC and CH bond angles in benzene are 109.5 degrees or 109.5 degrees, 120 degrees and 120 degrees, 120 degrees and 109.5 degrees, or 109.5 or 120 degrees. The correct option is 120 degrees and 120 degrees. We have studied in the X-rays के जितने भी bond lengths हैं that are of 120 degrees. So this was all about the structure of benzene. I hope you have understood it well, and thank you so much.